All right, hi everybody. Sorry I can't be here today, but it's kind of like I'm here. Here are notes for Unit 0, 1.1, okay? So these aren't going to take very long, but first let's kind of review some basic principles about number sets, okay? You need to know what counting or natural numbers are, whole numbers, integers, rational, and then irrational numbers, and then of course that's how we have real numbers, okay? But more specifically, they have specific examples here for counting or natural. If you remember the word counting and think about how you start to count, 1, 2, 3, 4, and so on, you never count by saying 0, 1, 2. That's your counting or natural numbers, okay? So 1 and higher, no decimals, no fractions, okay? Whole numbers. Well, the only difference between whole numbers and counting or natural numbers is this 0 here. Okay, so we still have everything we had before, but now we're adding 0. Okay? Integers. So for integers, it's what we have above. So hopefully you're noticing that we just keep getting larger and larger between these sets of numbers. But we have 0, 1, 2, 3. That's our whole numbers. And now we just add in the negatives, negative 1, negative 2, negative 3, and so on. Again, no decimals or fractions that are in between these, just these values, okay? That's our set of integers. And here are the symbols. Kind of use this fancy N for natural numbers, this fancy Z for integers, and this fancy Q for rational numbers, okay? Rational numbers, hopefully you remember that if you see the word ratio, what that means is that the numbers can be written as a fraction. Okay, that's what this notation means right here. X is rational as long as X can be written as a fraction, A divided by B. Okay, and obviously you cannot divide by 0, so that's not possible. Okay, but any fraction is rational. Any number that does not start out as a fraction, for example, 0.5, we know that that's 1/2. So if you can take a decimal and write it as a fraction, it is rational. 5, well, that could be written as 5/1. So even integers are rational numbers. Okay? So all these rational numbers, whole numbers, and counting numbers, those are all rational by default because they can all be written over 1. Now, the one thing you do have to remember is decimals that end, like 0.75 or 0.5, those can always be written as fractions. And so can decimals that repeat. So 0.3 repeating is 1/3. Those are some examples of decimals that can always be written as fractions. So those would be rational. Okay, and then irrational means exactly the opposite. There's no fraction representation for these decimals. So for example, the square root of 2 is 1.41 and so on. There's no pattern to the decimals. It doesn't repeat ever. It doesn't end. That's what we mean by irrational. And everybody knows the famous example, pi. Pi is an irrational number also, 3.14159 and so on. No repeating decimals there, and it does not end. Okay? And together, all of these numbers form the real numbers. Okay? So really a nice way to remember this stuff, if you want to write this down, okay, real numbers include irrational and rational numbers. Okay, so we start by doing this. And now, anything that's an integer, so we just work backwards here, is rational. Anything that's an integer, I'm sorry, saying that backwards. Within the set of integers, we have whole numbers, and within that, we have the counting numbers. Okay, so in other words, 3. Well, 3 is a counting number. If it's a counting number, then it's everything above that. It's a whole number, it's an integer, it's rational, and it's a real number. Okay? Something like the square root of 5. The square root of 5 is irrational because there's no repeating decimals, there's no termination with the decimals. So if it's irrational, it's also a real number. Okay, so that's kind of how this map works. All right? Now, as far as these examples down here, so this is really the bulk of the section, is linear equations, which should hopefully be a review, my recommendation here would be to maybe pause the video, take a minute, try the first problem, and then resume and see if you did it right, and do that with all 4 of them. Okay, I'll go through how to do all 4, and then also review with you how you can check your answers on the calculator real quick, because you want to make sure that you're doing quality work here. So especially when you start doing Math Excel, you don't want to make a little mistake, put in a wrong answer, and then have to redo everything. So we'll do all that. Okay, so starting with 9x plus 7 equals negative 12. Basic linear equation. The idea is that you want to subtract or add first, and then divide or multiply, just working backwards from the order of operations. So if I'm trying to get x alone, you can subtract 7 from both sides. And whether or not you write the minus 7, I'm not too particular about that. I would hope at this point in the game that you guys can just move numbers and terms from side to side. Okay? If it helps you to write it down, that's totally fine too. Next, you would divide by 9. So we get that x equals negative 19 ninths. Okay, and now the expectation is we're going to leave it as a fraction, so always do math, frac, okay, so math button, first option, and that converts it to a reduced and exact fraction if possible. Okay, so we're going to leave it as negative 19 ninths. Unless it asks you to round in the homework or on a test, then you would use the decimals and figure out how to round from there. Okay, so now as far as how to store or how to check answers on the calculator, there's a little button above the on key that says store. Okay, STO stands for store. So a good way to check your answers is you take whatever answer you got, press the store button, okay, or if you want to type in the answer, negative 19 ninths, and then the store button, you can store that value into x. Okay, so now every time you press x, it knows to use negative 19 ninths. Okay, so if I take x plus 1, it's going to add 1 to it. Okay, so a good way to check my solution here is to type in the left-hand side of the equation, which is 9x plus 7. You get negative 12, and that matches the right-hand side. Okay, if we have more variables on different sides, like this one, you would type the left side in, see what you get, type the right side in, see what you get, and if they match, then you are in perfect shape. If they don't match, then either you made a mistake or maybe you typed it in wrong, but it's good to always check your answers. Okay? All right, so for this one, we would distribute first. So that'll be 4x minus 32. And then you want to subtract 3x on both sides to get all the x's on one side. And then now you can add 32. So now you get positive 31 equals x. Okay? And then real quick, if you want to check your answer, you do the same thing we did before, but now you got to take 31, store it into x, and now type in the left side. So 3x minus 1 equals 92. Type in the right side, that's 4 times x minus 8, also equals 92, so I know that I did everything right. Okay? So that's how you check answers in the calculator. If you want to pause it and try number 3, then you can resume after you've done it. Otherwise, here's how we do it. Distribute on both sides now, so negative 12x plus 144. Distribute the negative 9, so that's going to be negative 9 minus 63x. Okay? And now we're just going to move some stuff around. So if I add 63 to the other side, okay, now I'm going to get 51x plus 144 equals negative 9. Okay? And then now you can subtract 144. So that'll be negative 153. Okay? And then from there, the last step would be to divide by 51. So if you do that on both sides, you get negative 153 over 51. And now I would just make sure, oh, that actually reduces to a nice answer. So this is x equals negative 3. Okay? And again, if you take that, plug it in to x, store it into x, type the left side, type the right side, you should get the same thing on both sides. Okay? Last problem. It does not start out looking as nice and easy as these because we have fractions here. So a good way to get started is to think about this 2 and this 3. If you were to actually add these together, okay, you would make these both 6 because you can multiply that by 3, multiply that by 2. Okay, that 6 is what we call the least common denominator. Okay? And a great way to start whenever you see a fraction problem is to take the entire equation and multiply it by 6. Okay, so I'm going to multiply everything by 6. And now what's going to happen is the fractions will cancel out because you're going to do 6, because it's really 6 over 1. But the 6 is going to get divided by 2, and that gives you 3. You still have the x plus 3, though, so I'm going to write that down. Okay. For the second fraction, if I take the 6 and multiply it, so I'm multiplying it to everything there, the 6 will get divided by 3, leaving a 2. But we still have the 5 plus x. I'm going to write that down. And now over here, there's nothing to cancel the 6, so I'm just going to do 4 times 6, which is 24. Okay? Once you do that, now it looks just like these other ones. We're going to distribute to get 3x plus 9. Distribute here. Be careful with the negative. That's minus 10 minus 2x equals 24. Since we have all our x's together on one side, now I'll combine them. Combine like terms, we just get a single x. 9 minus 10, that's minus 1. Okay? And now if you add 1, your final answer is x equals 25. Okay, so that's a nice quick review for how to solve linear equations. Okay? All right. Time to, I guess, start Math Excel, and we'll see you guys later. Bye.